Okay, welcome back. We're going to complete our discussion today on inverse trig and antiderivatives. And for the next three examples, we're going to have to use completing the square. So if you forgot how to complete the square, that's okay. We're going to revisit it. Now, when I look at number 7 here, we want to find the antiderivative of 1 over x squared minus 4x plus 7. Now, the problem here that we have is that we really can't integrate this. I'm trying to do u substitution. The derivative of my bottom is 2x minus 4, but that's not going to cancel with anything at the top, so it's not going to work. So my only other choice I have to work with is my arc trig functions. And if I look here, this x squared minus 4x plus 7, if I go way up here to our notes, it kind of looks like our arctangent. And it doesn't directly look like it, but there's no square roots there, so that's really my only option. So what I'm going to do here is I'm going to complete the square to make it look like this. Because remember, if I'm looking at a squared plus u squared, this is a sum of perfect squares. And that's my hint. I have to do it, so I'm going to complete my square here. So if you forgot, that's okay. Let's take a look. When you complete the square, we're largely looking only at the first two terms. This plus 7, I'm going to leave it on the outside. So inside here, I'm going to take half of negative 4, which is negative 2, and I square that. So I'm adding 4 here. Now be careful. By adding 4, we change the value of the function. So there's a rule of math. We can do whatever we want. For example, if I have 1 plus 4, I know that that's 5. But what if I take this 4 and I divide it by 3? That is no longer the same question, so it's no longer the same answer, so we really can't do that. But what if I divided by 3 and then undid that by multiplying by 3? Those 3's would, of course, cancel, and we get the same answer. Now, this is purely like an academic exercise, but we can apply it to this example. By adding that 4 on here, I can fix it by subtracting 4 on the outside. And now that gives me a perfect square. This becomes x minus 2 squared plus 3. So when I rewrite my integral, it's going to be dx over 3 plus x minus 2 squared. I would highly recommend you write it in this order, because remember, arctangent is 1 over a squared plus u squared. You really should have your x on the right side. So this is my arctangent. A is just root 3. U is x minus 2. Du is just dx, which is nice. We're not dividing by anything. So arctangent, 1 over root 3, 1 over a, right? Remember arctangent, wrote it right here. 1 over a, u over a plus c1. So 1 over a, arctangent u, which is, we said was x minus 2 over root 3 plus c1. Don't forget your c1 there. For number 8, same thing, but be careful. When I do complete the square, again, I'm only interested in the first two terms. But you might remember from last year, this term has to be 1. So I'm going to factor out that 2, and I get x squared minus 4x plus a blank space plus 10. Same thing, I'm going to take half of negative 4, which is negative 2, and squared, I get 4. Now be careful, I'm not going to subtract 4 here. Remember, last we had to subtract 4. I am multiplying by 2, so I'm really having to subtract 8 there. So you got to be careful with that. So when we do this one right now, we're going to get when we rewrite it, we would get dx over, this just becomes 2 plus, and this becomes 2 times x minus 2 squared. Now, I'm going to do something a little bit different here. I'm going to factor out the 2 on the bottom, mainly so it doesn't cause me any trouble. dx over 1 plus x minus 2 squared. Whoop, not du, but dx. There we go. So my a is going to be 1. My u is going to be x minus 2. My du is just dx. There we go. So when we write it, this is again arctangent. We get 1 over 1 over a, arctangent u, which is x minus 2 over 1 plus c1. Just don't forget that constant, that 1/2 there at the very beginning. And there's our antiderivative. I'm pro-derivative personally. All right, let's try number 9 here. Same thing, just going to complete the square. I'm going to go and start it. X squared plus 4x plus a blank space plus 13. Half of 4 is 2. Square root of 4. I have to subtract 4 to fix it. And if I rewrite it, remember this is just 9 plus x plus 2 squared. So when I rewrite my integral, I should just write that up. 9 plus x plus 2 squared. A is 3. U is x plus 2 with du equaling dx. And that's a 9 right there. That's a weird 9. So my arctangent, we get 1 over 3. Arctangent, x plus 2 over 3 plus c1. And there's our final answer. Amazing. It's easy stuff to do. All right, so try this one real quickly. Ready? So again, this is just arctangent. Oh my gosh, this is from the AP test. Look how easy this is. What's A going to be? 4. What U be? X. Always check. Du is dx. Always check that. So when we write this, this is going to be my arctangent. 1 over 4 arctangent U over A, which is 4, plus C1. And which one does it line up with? Of course, C. And there's our answer. Hope you guys enjoyed the video, and I will see you guys later. Bye-bye.